In this video, we are going to review the 5 main ideas that we learned in Chapter 9. The first one that we talked about is the Pythagorean theorem. And remember, the Pythagorean theorem is a squared plus b squared equals c squared. Well, what does a, b, and c represent? This has to do with a right triangle where a and b are the legs and c is the hypotenuse. Okay, and remember the hypotenuse is always across from the 90-degree angle. There are some specific Pythagorean triples where all 3 measurements of the sides are integers, so not a decimal. Some of the more famous ones are 3, 4, 5 triangles or 6, 8, 10. Sometimes it can be helpful to memorize these because you'll come across a triangle where it will give you 2 sides and you have to know the third side. And if you see that 2 of the sides are part of these Pythagorean triples, then you can automatically know what the third side is because you've memorized it. So that's optional but helpful. When do we use the Pythagorean theorem? Well, first of all, we can only use it with a right triangle. Okay, so that theorem is not going to work if we have an obtuse or acute triangle. It won't be equal. And we can use it to find the missing side. We can also use to prove that a triangle is the right triangle. So if we see that a squared plus b squared does in fact equal c squared, then we know it's a right triangle. Okay, if we see that a squared plus b squared is greater than c squared, then we have an acute triangle. And if a squared plus b squared is less than c squared, then we have an obtuse triangle. Okay, so here's a couple examples of when we can use the Pythagorean theorem. In number 1, it wants us to find the missing side length. So remember, we're using a squared plus b squared equals c squared. Which of these sides represents c? Well, remember, c is always opposite of the 90-degree angle. So we're going to be putting 9 in for c. And then 7 and x are the 2 legs. So I'm going to write 7 squared plus x squared. And now I just need to isolate x. So I'm going to subtract from both sides. And I get 81 minus 49, which is 32. And then I take the square root of both sides. So I get x equals the square root of 32. And you can leave it like that, or you can put it in decimal form. It just depends on what they're asking for. In our second example, it says to decide whether the triangle is acute, right, or obtuse. So we're going to be using this theorem right here, the converse theorem, okay? We're going to check to see if a squared plus b squared is equal, greater than, or less than to c squared, to see which kind of triangle it is. So remember, the longest side is always the hypotenuse. So we're going to have 5.3 squared plus 6.7 squared, and then we have 7.8 squared. And so we're going to put that into our calculator and see if they are equal, greater than, or less than. Okay, so 7.8 squared is 60.84. This one's 28.09. 98. Okay, 72.98 is greater than 60.84. So if we go over to our little chart here, we can see that when a squared plus b squared is greater than c squared, we have an acute triangle. Okay, so the answer would be acute. All right, the second topic that we talked about in this chapter is special right triangles. The first special right triangle is a 45, 45, 90 triangle. And these have special properties. When the sides are both 1, the hypotenuse is going to be square root 2. Basically, whatever the legs are, you're going to multiply that by square root of 2 to get the hypotenuse. So for example, down here in number 1, we see that the side or the leg is 8. So all I have to do is multiply that by square root of 2 and I get the hypotenuse. And with the 45, 45, 90 triangle, the legs are always equal to each other. It's an isosceles triangle. In our 30, 60, 90 triangle, the relationships are like this. When the short side is 1, the hypotenuse is double that. The hypotenuse is always the shorter leg times 2. When the short leg is 1, the longer leg is square root 3. So the longer leg equals the shorter leg times square root 3. So when we look at our example 2 here, it's giving us the hypotenuse. Okay, so we're going to actually work our way backwards. Our short leg times 2 equals the hypotenuse. So if I divide both sides by 2, then I get y equals 12. And remember, our longer leg, x, is equal to the shorter leg times square root 3. Okay, so we have our y and our x. The third thing that we talked about in this chapter are trigonometric ratios. And remember, sine, cosine, and tangent are all ratios of a right triangle. So we use sine, cosine, and tangent with right triangles. They also help us to find the missing side. When we have one side and one acute angle. We have sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And tangent theta equals opposite over adjacent. Now, what does this opposite, hypotenuse, adjacent stuff have to do with? Well, remember, when we have a right triangle, the hypotenuse is always the one that's across from 90 degrees. Theta is one of the acute angles, so you have to decide which angle you're referring to before you figure out what is opposite and what is adjacent. So if we decide to do that top left acute angle, then opposite of that will be this leg right here, and the adjacent leg is the one right next to it. The other thing that can help you remember this is to memorize SOHCAHTOA, because that S stands for sine, O stands for opposite over hypotenuse, cosine, the C stands for cosine, which is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So that's what those letters mean. So if you can memorize SOHCAHTOA and write it at the top of your test, it'll help you to remember those ratios. Okay, so let's do a couple of examples using these trigonometric ratios. So in example 1, we're just going to look at angle K and set up the ratios. So sine of K, cosine of K, and tan of K. Okay, remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's figure out which side is which. First, we need to circle K and then label the parts of the triangle. So 17 is the hypotenuse. The leg that's opposite of K is 15, and the leg that is adjacent is 8. Now we can fill in the numbers for these ratios. So we have opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. In number 2, we are going to use these 5 steps to help us solve for W and for V. Let's start by circling our angle. Okay, and then we're going to label the sides in reference to that angle. So this is the hypotenuse, W is the side adjacent, and V is the side opposite. So if we want to find V, then we need to use the angle we're given and also the side length we're given with this guy that we're trying to find. Which function is that? Which function has hypotenuse and opposite in it. Okay, we can see that it's sine. Sine is the function that has opposite and hypotenuse. So that's what we're going to write down. We're going to write down sine of 71 degrees equals opposite, which is v, over hypotenuse, which is 5. So we set up the ratio and fill in the given information. And next we want to solve for the variable. We're going to isolate v. So let's multiply both sides by v.
I think you meant 5, Mrs. Whiting.
Now we can just plug that into the calculator and we get 4.7 is equal to v. The next one they want us to find is w. Okay, so to find w, w is adjacent, and the one we have given is hypotenuse. So which one of these three has adjacent and hypotenuse in it? It's cosine. So I'm going to write down cosine equals adjacent over hypotenuse. And then we just fill in the numbers that we know. So cosine 71 equals adjacent, which is w, over hypotenuse, which is 5. We're going to multiply both sides by 5, and we get 5 cosine 71 equals w. And when I plug that into the calculator, I get 1.6. How do we plug those into the calculator? So to put sine into the calculator, you would put 5 sine and then 71 degrees. Oops. Like that. And we do not need a 0. Okay. And we see that our answer is 4.7. So that's how we got that. Okay. And if I were to put in 5 cosine 71, we get the 1.6. So that's why it's really important to make sure that we're using the right tangent, cosine, or sine ratio, because we do get different answers with those. What if we need to find the angle measurement? Like we're working backwards. We don't know the angle, but we're given the sides. This is when we use the inverse trigonometric functions. The inverse helps us to find angle measurements of a right triangle. Once again, all of these are being used with the right triangle only. And we need to have at least 2 side measurements. All right, so what we do is we have sine -1 of the ratio, which is opposite over hypotenuse, equals theta. Adjacent over hypotenuse equals theta, and tan -1 opposite over adjacent equals theta. So remember, this -1 is not an exponent. It's just saying that we are taking the inverse of sine, cosine, and tangent. So we are going to follow some of the same steps to find that missing angle. So down here in example 1, it wants us to find the measure of angle B. So that's what I'm going to circle. And then I'm going to label the triangle accordingly. So I have hypotenuse. 9 is going to be opposite, and 12 is going to be adjacent. So which 2 sides are we given? We're given adjacent and opposite. So we're going to look at which one of these functions has opposite and adjacent in it. Well, it's tangent. So I'm going to write down tangent -1 opposite, which is 9, divided by adjacent, which is 12, is equal to theta. And then when we go to put this in the calculator, if you're using the Desmos calculator, you can see there's no -1s on here. So what I have to do is I have to hit function, okay, and then those pop up. We are using tangent -1 of, then we need to go back to main so we can get our numbers, 9 divided by 12. And we get our answer. Our answer is 36.8 or 0.9 degrees. Okay, so 36.9 degrees. And that's how you find the missing angle measurements. From here, you can just, if you want to find the other one, you can just do 180 minus 90 minus 36.9. Okay, or you can use trig again. Either way will work. So that was the 4th thing that we learned. The 5th thing that we talked about was angles of elevation and depression, and then solving right triangles. So what is an angle of elevation? Remember, the angle of elevation is the angle between the horizontal and the line of sight when looking up. Okay, so if you have a little person and they're looking up, okay, that angle of elevation will be right there. The angle of depression is the angle between the horizontal and the line of sight when looking down. Okay, so if you have a little person and here's your horizontal, it's still coming straight out, but instead of going up, the line going up, it's going to come down. Okay, so that's the angle of depression. What methods can be used to solve all of the pieces of a right triangle? Well, we've learned several things in this chapter. Sometimes we can use a squared plus b squared equals c squared to help us find the missing side of a triangle. Sometimes we can use the triangle sum theorem, right? All three angles add up to 180. We know two of the angles. We can use subtraction to find the third one. We can use sine, cosine, and tangent. And we can also use the inverse of sine, cosine, and tangent to find those missing angle measurements. So if we're given two side lengths, let's say we're given 3 and 4 here, and that this is a right angle. First, we could use a squared plus b squared equals c squared to find the hypotenuse. Then we could use one of the inverse functions to find one acute angle. And then we could use the a plus b plus c equals 180 to find the third acute, or sorry, not third acute angle, just third angle. Okay, so we don't always have to use sine and cosine for everything. We could use a combination of methods to help us find the missing parts of the triangle. Let's say we're given one side length and one acute angle measurement. So if we had 3 here, and then this angle right here was 36.9, we would first use a plus b plus c equals 180 to get that other angle. And then the next thing we would do is use trig, use sine, cosine, tangent to find the two missing sides. Okay, so if we were to go back to some of these other questions we did, we could use these methods to help us find all three pieces of information. For example, in number 2 here, we already found the two sides, V and W, but we could go back and find this third side by simply doing 180 minus 90 minus 71. That equals 19. So the other angle is going to be 19 degrees. Okay, and then we found all the missing parts. If we look at number 1 here, we found B. We found B is 36.9, and we could do 180 minus 90 minus 36.9 to find the other angle. So this one is 53.1. And then we could actually use a squared plus b squared equals c squared to find our third side, right? So 9 squared plus 12 squared equals c squared. 25, which is 15. Okay, so this equals 15. So now we've found all the missing sides and angles of this triangle. All right, hopefully this paper will help you with the practice test. And also it's a good paper to study and to memorize the different things that we've learned. Good luck.